Your presenter today is Dr. Klaus Tenbergen, Director of the Culinology program at CSU Fresno. Assisting him are Jason Pimentel, a Culinology major, and Angelica Robles, a nutrition major. Dr. Tenbergen?
Thank you and good afternoon. I'm very excited to hold this web seminar today because I feel for you, meaning I have the same struggles a lot of you experience when teaching our students the applied math in the classroom, especially in culinary arts. Today I have prepared several props we're going to use throughout the lecture. However, we can use these also in a lab setting, depending as your time allows. If you have a normal lecture session of 50 minutes, this would be very appropriate. If you teach labs like I do for 1 hour and 50 minutes, this can be extended where the students actually can do a lot of things hands-on. So let's start off with the basics. The basics for me is explaining the difference between cooking and baking to the students. So I'm going to interact with my 2 assistants here today, and I'm going to ask them questions just like you would do when you deal with your students. So my basic question to the students would be, what is the difference between cooking and baking? Angelica, what is the difference between cooking and baking?
Well, thinking cooking is more, you can change it up. So if there's a recipe, I don't have to really stick by it.
Okay, so you're using a recipe as a guideline?
Yeah,
Okay, and in baking, what would you do different?
I would stick to the recipe all the way because if you try to do the exact same thing as in cooking, the baking, it comes out wrong and you won't know until you get the end product.
So we say cooking is an art and baking is a science. In cooking, for example, you take salt at any time throughout the cooking process and add it whenever it's needed. In baking, if you forget the salt, the relations between the flour, sugar, fat, whatever else you use in the formula are off balance, which then has an impact on the finished product. So bread made without salt will not work out. So in baking, we use science, which is based on scientific studies. That's why the mistakes, as Nina mentioned it earlier on, people think that culinary arts is the same as culinology. Culinology is based on 50% of science and 50% of culinary arts, where culinary arts is more a trade-based program where we apply different kind of skills to people. Now, my biggest struggle is in the daily classroom is how to apply the math learned at the high school level to the classroom and to the lab setting. To make students understand this, I use simple methods and then applied methods, which again we have here prepared for you for later use. So Jason, you and me, let's create a gallon monster for our viewers to see how they can explain the breakdown of the different units of measurement in the United States and make the students better understand how these things interact. So why don't we start drawing here on the whiteboard, which is as easy as this, and start with the gallon as our unit of measurement. So we have 1 gallon in the middle. We also use the appropriate abbreviation, GAL. So the next question would be, Jason, what is the unit below gallon? And Jason's answers would be?
Quart.
Quart. How many quarts are in a gallon?
4.
4, okay? So now Jason is going to draw 4 circles around the gallon, which resembles the 4 quarts in 1 gallon. And again, he's going to label that QT for quarts. Again, Jason, what is the unit below quarts?
Pint.
Pint. How many pints in each quart?
2.
Okay, so each quart gets 2 circles for 2 pints. Now, while Jason is drawing all of these little circles, let me ask Angelica a couple of questions. How many quarts are in a gallon? Come closer, please.
4.
How many quarts are in a gallon?
4.
4, and how do you figure this one out? 1, 2, 3, 4. The question is now, how many pints are in a gallon? Come a little bit closer to me. How many pints are in a gallon?
So there's 2 at each floor, so that means 2, 4, 6, 8.
8. Okay, there's 8 pints in a quart. No, wrong. There's 8 pints in a gallon. So if I ask you now, how many pints are in 2 quarts?
So there's 1, 2 quarts, and at each quart there's 2, so 2, 4.
2, 4. So it makes it very easy to see what's going on here. Now, Jason, the unit below pints is?
Cup.
How many cups in a pint?
2.
2, okay. So we make more circles. And funny enough, to do this, I do one step further. I ask the students to generate this gallon monster at home as part of a homework assignment, but I have them computer generated, which then will allow me to look at their computer skills. So they're not learning these things in the classroom, but they're also looking at these computer skills as needed. So you see it becomes very colorful and pretty big for that matter. But it helps them, especially the visual learner, to understand how we use different systems throughout the classroom. And all of these, which I'm going to explain later on, going to be applied to a lab setting when dealing with recipes and formulas in culinary arts. So now we can write this down here. So we say 1 gallon. 1 gallon equals 4 quarts. 1 quart equals 2 pints. And then 1 pint equals 2 cups. Now, my next question to Jason would be, 1 cup equals, what is the unit below cups?
Ounces.
Ounces. How many ounces in a cup?
8.
8. Okay, so we would break down the cup into 8 ounces. Now, as you can see, this little drawing of ours gets big. So we just concentrate on one arm of the cup by making little drawings like this. And depending on how creative the students are, the funny thing is actually that I give it a theme. So I said, okay, this semester it's due during Halloween, so it's going to be pumpkin. So everybody had to draw this giving a pumpkin theme. If I teach a semester in the spring, then I may say it's going to be Valentine's Day, and everybody has to make little hearts. Depends on how creative they want to be. Otherwise, they're just using round squares. Again, I'm also looking for computer skills which they can use at home and their level of computer skills. So, Angelica,
Yes.
if each cup has 8 ounces, then 2 cups have
8 plus 8, 16.
16. Okay? If I have, now we can count, as simple as this. We start somewhere here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 cups in a gallon. If I have 16 cups in a gallon, and each cup has 8 ounces, then my calculation would be,
Get 16 cups,
oops, 16 cups
multiply
by
by 8.
8 equals, 16 times 8 is, and a calculator comes handy. A simple calculator which can be bought somewhere like this, I request the students to have, because I'm not really worried about the answer. The calculator will give you the answer. That's not the big issue for me. What the issue is, if the students do not know what to put in the calculator, they will never get the answer. So I break it down in little steps like this. So 16 times 8 equals?
128.
128. 128 ounces. If I have 128 ounces, I know that a gallon has 128 ounces. I know that a cup has 8 ounces, 2 cups has 16 ounces, 4 cups has 32 ounces, 8 cups got 64 ounces, and 16 cups got 128 ounces. I break it down. Now we make it challenging. It depends on what level you teach and depends on how much you're expecting from your students. We can break it further down. Jason, what is the unit below ounces?
Tablespoon.
How many tablespoons in an ounce?
2.
There's 2 tablespoons in an ounce. So here we're creating our gigantic gallon monster, which then consists of 2 tablespoons in an ounce. Now, if we multiply the 128 times 2, because there's 2 tablespoons in an ounce, then I know that I have 256 tablespoons in a gallon. And remember, I'm teaching mathematics. I'm not so much worried about how this applies. The next question would be, how many teaspoons are in each tablespoon? Which would be? 3. Okay? So we're extending our monster to 3, and we keep going. Nina, you have a question?
I don't have a question, but I do have a couple of people that are having problems with the visual. The visual should be in the small square on the left-hand side, upper side of your screen. And the sound is on. Those of you who don't have sound need to check your computer. Make sure that the sound is on with your computer. And also, I believe that you're able to put your, yes, there's a volume at the bottom of that screen that's on the left-hand side also. So check that and make sure that the sound is on there and that it's not turned off. Excuse me. Thank you very much.
That's perfectly fine. And I welcome questions. So if I go too fast, please interrupt me or send a little message to Nina. Nina will moderate it towards me, and I try to answer as many as possible. And I have to have a little cheat sheet sometimes because, again, I do not remember most of the numbers. What I do remember is how I get to the final numbers. And again, I say it again, it doesn't help to have a calculator, but if you don't know what to put into the calculator, it makes it really difficult for the students. They will never find the answers. That's why we have those. Actually, as a little teaching tip, I require them to have a calculator which fits into their breast pocket of their uniform if you have a lab coat or a uniform which has it. So once I created the gallon monster as a homework assignment, or maybe you as a handout, and we will post these gallon monsters which are prepared for everybody on the website for everybody to use after the web seminar. Then I ask the students to print this out and I bring it to class, with each class, so they can actually use it in the lab setting, what they learned in the lecture setting. Okay? So we determined there's tablespoons and teaspoons. But then there's 3 more units which you can deal with, and maybe you pose it as a homework question. So my homework question to the students would be, if there is, what is the units below teaspoon? You know, Jason, do you remember that? No. There's a dash, right? So how many dashes in a teaspoon? Big question, right? Like me, I have to look it up. There is 8 dashes in a teaspoon. Then there is 12 drops, which equals 2 dashes, which equals 1/4 teaspoon in a gallon. And again, there is 6 drops in 1 dash. So one of the challenging questions I pose, depending on the level of students you teach, is how many drops in a gallon? And again, it's not there necessarily to make their life difficult, but for them to understand the mathematics behind this whole thing. And so it would break down to something simple like this. If you multiply the amount of ounces in a gallon, multiply those by 2, because there's 2 tablespoons in an ounce, then there's 3 teaspoons in each tablespoon. So you keep multiplying 128 times 2 times 3. And then again, there is 6 dashes in a teaspoon times 6. And then if you think that there is 6 drops in each dash, you multiply that number times 6, and you get something like 34,685 drops in each gallon. So this is how I explain the basic of the gallon monster, what I call it, to the students in lecture, during lecture. Once I explain this in lecture, I have them print it out, use it in the back of their binder so they can use it actually in class. And if they have to multiply recipes by 2, by 4, by 6, and one recipe calls for a quart, and they have to divide the quart by 2 because they have to have the recipe, they know each quart has 2 pints. 2 pints equals 2 cups. Each cup has 8 ounces, and there's 128 ounces in a gallon. So that would be one of the things I use. But we can make it even more interesting to the students. Let's just wipe out our board quickly so we can reuse it for the next exercise. The next thing, how I teach students, is using metric. Metric in the classroom. Everybody's afraid to use metric, but in reality of things, we're using metric all the time. Angelica, where do you use metric in life, every day? Does anything come to mind?
Not at first, no. I can't think of anything.
Okay, so let me help you along the way. I'm looking for something, right? Yes, there it is, my $1 bill. And I explain it through money. As simple as this. Metric is a system where we use units of 10. So the question to my student is, how many dimes are in a dollar? And the answer is?
10.
How many dollars in $10?
10.
How many $10 in $100?
10.
And Jason, how many $100 in $1,000?
10.
You just earned yourself $1. Oops, I'm sorry. So, he gave more answers, right? But he gave the right answer at the end. Okay, so, if one of the students get admitted to hospital and you're totally dehydrated, what is the first step they do in the hospital for dehydration?
They use IVs.
They use IVs, right? And they put you in IV. And they normally tell you how much IV fluid you get.
Which is through milliliters or liters.
How many?
1 liter.
1 liter, right? A metric system. A metric system we know, when nobody knows what 1 liter is, we just take it as it's being there, and we don't really know what that means. So what is 1 liter, and how do we measure 1 liter? Well, the very first thing I teach my students is the metric number. The magic number is, Jason?
28.35.
28.35. And what do I always tell them? I said, when I call you, you see my name on the caller ID, you're going to say, hi, this is Jason, and the magic number is?
28.35.
I try to make it funny. I try to make it entertaining. I try to make it so people can relate to it, and it becomes a story. And when I test the students and I see that the students get it, then I can move on. If I see the students struggle along the way, then by evaluating the feedback I get from the students, if Jason would have said, no, the magic number is either I don't know, or the magic number is something which is not 28.35, I know I still need to work towards the goal. Once you embed that number, 28.35, which is really important, because I'm going to show you the relations between 28.35 grams and everything else. So, if the magic number is 28.35, it means there is 28.35 grams in 1 ounce. That's what the magic number is all about. Now, we just learned that there is 16 ounces in a pound. 16 ounces equals 1 pound. But we also know that each ounce is 28.35 grams. So if I want to convert the ounces, into grams, I tend to find out how many grams are in 1 pound. I take 16 and multiply it by the magic number. And my calculator would give me now the number of 453.6. Now, how does this relate to anything? It's actually very simple. If you take something out of the fridge as simple as a pound of butter, and you look very closely, you're going to find that anything we use in the kitchen is labeled in both units, in American ounces and in grams. And if you look very closely on the box, it will tell you that there's 454 in this matter. There's 0.4 grams extra in the box right here, 454 grams in a pound. So now the student can relate the metric, the 453.6 grams, to what they're used to, which is a block of butter, for example, a block of yeast, a block of margarine, and so on. So that's another way how you can relate what you learn in the lecture into the classroom. And that's why I'm using 28.35 as a magic number, because 28.35 relates to anything we receive in our environment. So we can relate any of this. Now, one of the things students struggle with is how to relate things. And Jason's going to help me out here by measuring out 1 cup, a simple cup measurement, 1 cup of flour. Okay? So we take a bowl of flour and we say to the students, okay, measure me out 1 cup of flour. And what we're going to find is exactly what happened to Jason now. They're going to scoop out flour randomly, pile to the top, and think that this is 1 cup of flour. And I said, remember I explained the difference between baking and cooking? We're going to bake today, and baking is a science. In baking, as Angelica stated earlier on, we have to be precise. So how do we get everybody to have 1 cup of flour, and or every cup of flour looks the same? Well, I use a simple tool like a bowl scraper. And a bowl scraper is nothing else than a straight surface, which I'm going to use then to straighten the surface of a cup of flour. Now, if every student does this, and you may have 20, 30, 40 students in a class, then you ensure that everybody has the same amount of flour. And this, whatever they do, is consistent to what you need. So, how do you apply the cup of flour to the classroom? Let me try Jason. Jason, a cup, would you write this down, please, for our viewers? A cup has how many ounces? We determined earlier on that 1 cup was how many ounces?
8 ounces.
8 ounces. Okay, Angelica, today we have a celebration. And with 1 cup of flour, we make 10 cookies. I want to make 100 cookies. How many times do I have to make the recipe to go from 10 cookies to 100 cookies?
Have to multiply it.
Multiply it by what number? From 8 to 80?
Multiply by 10.
Multiply it by 10. Okay, so we determine now this recipe makes 10 cookies. You write it here. This recipe makes 10 cookies. I want to make 100 cookies, right? So, and everybody loves cookies, right? So it's a topic you can connect to the student with very easily. So Jason, if I want to increase from 8 ounces, 10 times the recipe, then 8 ounces times 10 equals? 80 ounces. If you would write that down, please. But we also know that there's how many ounces in a pound?
The magic number.
No, how many ounces in a pound?
16 ounces.
16 ounces in a pound, very good. If they wouldn't have got the answer right, they could have looked at the gallon monster, right? Remember, I'm not so much into people memorizing, in memorization and people memorizing the numbers. Once they know where to find information, they look at the gallon monster each and every time, eventually they will memorize it. But they need to know where to retrieve the information. They need to succeed in the lab settings. So we also know that there are 16 ounces in a pound. So if I divide 80 divided by 16, which is the amount of ounces in a pound, it would give me a total of 5 pounds. 80 divided by 16 is 5. So it would give me 5 pounds. Okay? And I write it always on the board so student can follow along with what I'm saying. Now, we realize that a cup of flour or a cup of something is only a cup of something if this is the same gravity as water, because everything is related to the density of water. Now, how do I explain gravity and the density to a student? Well, as simple as this. I have 2 glasses. I fill both of them with water. And if the specific gravity of water is 1, and if I want to make a point of showing the students that if something is lighter than water, it will do what, Angelica?
It will float on the top.
It will flow on the top. So for example, if I take oil, which is lighter than water,
It's floating.
it will float. It will separate and float. Okay? And it's a cool science experiment on top of everything, right? So it determines that the oil is lighter than water. But if something is heavier than water, Jason, what's going to happen?
It'll sink.
It will sink. So what do? Picked up some rocks, right? To show that the rock's density is more than the density of water. So by putting rocks, for example, inside water, If something is denser than water, it will sink. If something is lighter than water, it will flow. Now, how does this relate back to the cup of flour? Well, as simple as this. If you take, for example, a cup of brown sugar, and again, we take the brown sugar, we straighten off the top. In every recipe you ever worked with, what does it say you have to do with brown sugar?
You have to weigh it.
Okay, if I measure it out in a cup, I don't weigh it, I go by volume. Jason, if I take a cup of brown sugar, what is the advice in each recipe they give you what to do with the brown sugar?
To pack it in.
To pack it, okay. So I'm going to pack my brown sugar. And what actually happens if I pack my brown sugar? Well, it becomes more dense, right? So you can see a cup, original cup of brown sugar, once it's packed, it's not a cup of brown sugar. There's something missing here, right? And what's missing is, it's the air I pushed out, because the air occupies space, and once I remove the air, I get free space. So here, for example, to relate it to the flour, I just said now that 1 cup of flour is 8 ounces. If I want to make 10 times the cookie recipe, I need 80 ounces, which gives me a total of 5 pounds. I had Jason weigh out a cup of flour. And I said, Jason, how much is a cup of flour? Not how much does it weigh?
8 ounces.
8 ounces. And I said, really? Why don't you take the cup of flour and weigh it for me?
Okay.
So to weigh a cup of flour, we do a couple of things. We always use electronic scales if they're available. Otherwise, a little kitchen scale will just work fine. And because it's a scientific lab I'm working out of, we only have scales which work in metric. Sometimes they're convertible between metric and ounces, but that's another reason why I teach metric in the lecture, so they can apply it into the classroom, because it's a scientific classroom. Okay? Whenever we scale something, we put a container on it. In this case, a glass bowl, so everybody can see what we're doing. Once you got the glass bowl on, we want to tear out the weight on the scale. So we press tear, we weigh it out, and then Jason's going to take the flour and put it on the scale to see if the 8 ounces of flour, which we originally measured out, is actually 8 ounces. And come to find out that the cup of flour is how many ounces?
4.5.
4.5. Wow. So what happened? Why is this not 8 ounces? Well, if you would take flour and you would again put it into water, what happened to the flour? It will float. Right? That means the flour is lighter than the water. So what's in the flour which makes the flour lighter?
Air.
Air. And how much does air weigh?
Nothing.
Nothing. But air does what?
I don't know.
Air occupies the space, right? So air weighs nothing, but air occupies the space. So the actual amount of flour in a cup is not 8 ounces, but 4.5 ounces. So let's do the calculation. So if 1 cup of flour equals 4.5 ounces, then if we multiply this by 10, remember we're making 10 times the cookies, so 4.5, 4.5 times 10 equals
45.
45 ounces. Now, remember we said there's 16 ounces in a pound. So if we divide that by 16, so we have 16, 32, right? That's 2 pounds, leaves us with 13. That gives us 2 pounds and 13 ounces of total weight. And for the students to understand the difference between the specific gravity or the density, for that matter, of the flour versus the density of water, what specific gravity is based on, you will see that there's actually a difference of 2 pounds and 3 ounces of total weight if somebody would have converted incorrectly using the understanding that 1 cup of flour is 4.5 ounces, which is the actual weight, versus what people believe 1 cup of flour is 8 ounces. So it's important, and it's important to show the student this hands-on, and you can either do it in the classroom or in the lecture room, just like I did, with little examples, or even better, you pose the question to the students and then take it to the lecture or to the lab and let them, what they heard in lecture, do in the lab. That always works well. Okay? So you see in the cup of brown sugar, when it's packed, where it takes out the air, which makes it more dense, the cup of flour, and how the density of different items is related to the specific gravity of water, which is 1. But you also see in that 28.35 grams times 16 equals the amount of grams or ounces in 1 pound of butter, which you find in every refrigerator in every school, wherever you work. Something related to measuring and how to do this is to teach a student how to do the meniscus. The meniscus is something, again, something you can show them on a table during your lecture, or even better, let them do it in the lab setting. Angelica, would you take, please, one measurement and, for me, measure out 16 ounces of liquid. And I'm just choosing 16 because it comes to mind. Now, if you look at the measuring cups, the ones I use, they have 16 ounces or units of 2 ounces on the side. On the other side, they actually have metric measurements, so you can use them for both. Okay? So I have the students then measure out 16 ounces, as you will, of liquid. Okay? So the student does it, and she says, right there, 16 ounces. And I say, not right. Jason, could you check for me, please? Is this 16 ounces? Let's see what Jason comes up with. It looks like, at least from the top, right? Yeah. But if you actually do the meniscus, which means bring your eye level to the eye level of the liquid, if you go down a little bit like this, you will see that because the water is curved like this, it is not 16 ounces, right? So there's actually quite a bit of space still left. So believe it or not, if you put your eye level on it, tell me when to stop. Okay, see how much more I added? And so you can use this kind of examples and transfer what has been explained here on the whiteboard into the classroom. Even things like the meniscus, how to weigh out things properly if you do it by volume measurement. Do you have any questions yet, Nina? No, I don't. Guys, questions, please. Okay, so let's see what we covered so far. We talked about the gallon monster. We talked about the pound of butter, the brown sugar, the cup of flour, how to measure and weigh out, and using specific gravity by using water as the base, and then using oil and flour as an example. A little bit of meniscus, how to scale, how to tear a scale once you use a bowl. That 28.35 grams is our magic number, and then how to convert from metric to American, from American to metric. And I will do this one more time just to explain this. If you can just wipe out the board. And it's as simple as this. Again, the magic number is 28.35. And if you use 28.35, another easy trick for the students to remember it. Once they have their calculator and they have it in their little pocket, in their pocket or apron, whatever they have space to, I ask them to take a permanent marker pen and write the magic number on the back of the calculator. Once it's there, again, remember, I don't want them to remember it. I want them to know where the number is. So if they need it, it's nothing easier than pull out the little calculator, look in the back, and say the magic number is 28.35. So again, after a while, they are going to memorize the number and then use the number throughout your whole setting. If you choose to use anything else, 28, 30 grams, that's also an option. However, again, if you use 30 grams and you multiply 30 times 16, 16 ounces in a pound, then it doesn't align with what you find in your refrigerator. So if you ask the students to do 480 grams of butter, which supposedly in your calculation would equal 1 pound, and this is actually only 453 grams in a pound, then you throw the whole recipe off. It's plus minus 8% difference in your calculation. Okay? So this is also an easy way to do. Okay, so how do you convert the one to the other? Well, it's very easy, right? We remember that 1 ounce equals 28.35 grams. That means if you have a number, anything like 6 ounces, for example, you just simply multiply it by the magic number, 28.35, which gives you the amount of grams in that 6 ounces. Again, I don't have the answer, but Angelica has a calculator, so if she puts in 6 times the magic number,
170.1.
that would give me 170.1 grams. As easy as this. This is important that they know the magic number and what to multiply it with and vice versa. Now, if I have, for example, a metric number, let's say 330 grams, how do I get it from grams into ounces? I divide it, not multiply, but I divide it by the magic number, 28.35, which then gives me the amount of ounces in this amount of grams.
11.6.
11.6 ounces. So you either divide it to get it from metric to American, you divide it by 28.35. To upscale from, or to scale from ounces to metric, you multiply it by 28.35, which gives you then the amount of grams in that amount of ounces. As simple as this. So here's another fun exercise I like to do, and Jason and Angelica, both of them, they will try to work it out on the whiteboard while I'm trying to guide them through the process. So my first question is, would you please hand me the box? The magic box. I have a lot of magic today.
Yes, you do.
This is a simple half case of eggs. As they come in the industry, we get them delivered as a half case or as a full case. So I pull out one of the egg trays. And my first question to the student is, how many eggs are on a tray of eggs when they're delivered wholesale?
I've heard a dozen of eggs.
Okay, a dozen. 18 eggs. Okay, it's as simple as this. There is 5 by 6 eggs on each tray. So 5 by 6 equals
5 times 6, 30.
30 eggs. Okay, now I'm going forward and backwards from American to metric, right? The second question would be, and you can write it down here for our viewers, if you can just clear the board. If there's 5 times 6, which is 30 eggs on a tray, that means how many dozen eggs are on a tray? And how do you get to that number? Again, I'm not interested in the answer. I'm interested in the thought process. How do you get to that answer? So we know that there's 5 times 6 eggs on a tray, which equals 30 eggs on each tray. Now, to get to ounces, we know that there's how many eggs in 1 ounce?
How many eggs in 1 ounce?
How many pieces in 1 ounce? In 1 dozen. I'm totally confused with my ounces now. I'm at dozen now.
Well,
I'm
a
at
dozen
dozen
of
now.
eggs is 12 eggs.
Okay, so we know a dozen is 12, right? And I have 30. So how many dozen is 30 eggs? And what do I do to get to that number? I take 30, you can write it down here. I take 30 eggs and divide it by 12, which is the amount of eggs in a dozen, which gives me
2.5.
2.5, 2.5. Okay, so I know that there's 30 eggs here, but I also know that there's 2.5 dozen eggs here. Now, the next question is remember, I want to relate it to actually what's happening in the industry, right? And what happened is actually required. I say to the student, how many eggs are in the box? And they say, I don't know. And I go, how many eggs are in the box? How many eggs are in the box?
15 dozen.
Right. It wasn't on here, it was on here, right? I want them to be not creative, but adventurous and actually look for it, right? If it's not on this side, which tells you that you need to keep eggs at 45 degrees, you look at this side, it says 15 dozen. So if I have 15 dozen of eggs in a box, and there's 2.5 dozen on a tray, how many trays are in each box? Jason. Again, if you write it down, there's 15 dozen in half a case. This is actually called half a case. A full case is double that. It's 30 dozen. So there's 15 dozen in a half case, and there's 2.5 dozen on a tray. how many trays are in each half case?
So then 15 divided by 2.5.
15 dozen divided by 2.5, which equals
15 divided by 2.5, 6.
6. So now the students realize that there is 6 trays of eggs in each half box. 6 trays of 2.5 dozen equals 15 dozen, which is the same what you see here, 15 dozen. Okay? So now we make it a little bit more interesting. What is the standard size of an egg in the United States?
Large?
Large, very good. So, one large egg is how many ounces?
5 ounces?
Okay, 5 ounces is a lot. Jason, do you have any idea?
2?
Okay, 2 is actually the correct answer. So, if one large egg is 2 ounces, now my question is to get it back to metric is, how many milliliters are in each egg? We know that there is 2 ounces in an egg. So how many grams in an egg?
You multiply that
By
magic numbers.
the magic number. There we go, the magic number. Okay, 2 ounces multiplied by the magic number is 2 times 28.35, which is 56.7. There we go. 56.7. And you see how you can interact, and they get excited by getting the right number on the calculator once they understand how to get to this number. Okay, so I know that there's 56.7 grams in each egg, right? Now, to make it more complicated and to make it more challenging for the students, and I hope you're not confused about this either, is I can ask a simple question like this. If an egg less the shell is not 56, but it's actually 50 grams. Okay? 50 grams in weight. The 50 grams consist of what's inside the egg? There's 2 parts in the egg.
The yolk?
The yolk and
The white.
the white. Very good. Okay, so you have yolk and you have white. Okay, yolk and white. Now, what are the proportions of the yolk and the white? Is there the same amount of yolk and the same amount of white, or is there more white than yolk? And the simple thing is, see, you can have them guess. Just take an egg and crack it open and say what looks like there's more of. Does it look like there's more white or there's more yolk? Okay? They go and inspect it, they look at it, and then they determine that there is
More white than yolk.
More white than yolk.
okay, so it must be more white than yolk. And it is. There is an egg consists of 30 grams of white and 20 grams of yolk. Right? As simple as this. So there's 4 parts of yolk, 6 parts of white to make 50 grams. So this is a whole egg. But I'm not done yet. Can you see I love mathematics and how that applies? And I said I can post one simple question as a final exam for a lecture class, and it's going to take them about an hour to answer, which would be how many milliliters of yolk do you get from half a case of eggs? Right? And how many egg white do you get from a case of eggs? Now the brain is turning, right? Okay, so how did we get there? Well, it's simple, right? We determined that there was 30 eggs on a tray. Okay? We know that there is in each egg is 30 grams. So if I take 30 and multiply it by 30, which is the amount of eggs on a tray, so 30 times 30 is?
900.
900. Okay, could you write this down? 30 times 30 equals 900. That would mean there's 900 milliliters of egg white for each 2.5 dozen, right? That also means that there is, if I take 30 eggs and I have each egg has 20 grams of yolk, I multiply 30 times 20, the amount of yolk in one egg, which gives me 600 milliliters of yolk. Okay, which gives me then a total of 1,500 milliliters of total. So one tray of 30 eggs would give me 1,500 grams / milliliters of whole eggs. And I always say don't burn rubber, which means if I have to walk from one side of the building to the other side of the building to retrieve some eggs for my recipe or for my formula, and I need 1,500 milliliters of egg, my brain is working. One egg is 50 grams, 1,500 milliliter is 1,500 divided by 30 equals, by 50 equals 30. I need to get 30 eggs. I know that there's 30 eggs on a tray. I bring back one tray. I don't go and bring 5 eggs and another 5 and another 5 and another 5, or I don't bring 6 of these trays because I don't know how much I actually need. And so once they are applied the math to a daily life, they're going to work out, and their brain is constantly working to try to figure out how can I work efficient versus wasting a lot of time walking forward and backwards to the cooler to get eggs, to the cooler to get butter, to the cooler to get milk, and so on. Okay, so my question was then, how much egg yolk and how much egg white does one case, half a case of 15 dozen egg yield? Final exam question. So we figured out that there is 600 milliliters of yolk and 900 milliliters of white on one tray. Now, if you go back to the beginning, we realized that there was 6 trays in each half case, which equals 15 dozen. That was my question. So I multiply 600 times 6, which is 3,600 milliliter, and I multiply 900 times 6, which is 5,400 milliliter. Thank you very much. I have somebody in the back giving me all the numbers. I wish. But you can see I love playing with numbers. And I let them, I'm normally not that fast giving the answers because I want them to give me the answers, right, once they understand how. So the answer to my question is, how many egg yolks are in half a case equals 15 dozen of eggs? The answer would have been 3,600 and 5,400, which gives me a total of 3,600 plus 5,400 is 9,000 milliliter grams. So if I want to know how heavy this is, 9 kilo plus the box and the eggshells. So as you can see, I try to apply mathematics in the classroom to what is really available in the fridge, what is available with our eggs, and there's many other examples where you can do this. I try to involve the students in measuring it out because, you know, a cup of flour is a cup of flour, right? Half full, full. This is not a cup of flour. This is a random amount of flour in a cup. There's a big difference. And we had this joke at the beginning. I said, what is the difference between cooking and baking? And you said?
Baking is a science.
And cooking?
Is an art.
And? Can everybody do it?
No, only the few can. It's
Can
hard
do
to
both,
both.
right? Only a few can do both. Because it's a mindset, right? When people are not, in order to do something precise, they like to cook. And cooks who can just take a little bit of salt extra and a little bit extra water and a little bit extra of this at the end and be pretty random using a recipe as a guideline, it's a way different way of thinking than, yes, I need 1 cup of flour, right? And 1 cup of flour is not half full and half empty. It is what it is. It is 1 cup. And that's where people struggle with who have the flexibility in a recipe, where in a formula, you have to stick to it. In a formula, to be successful, you have to weigh everything with the magic number. Nina, questions?
Dr. Tenbergen, do you sift that flour first? Is there a difference in the weight?
Yes, because sifting does 3 things. It removes impurities, so anything which is in the air and we don't have control of, anything from a fly to a piece of unwanted material, which even if the flour was covered, it combines ingredients. For example, if I want to combine my hypothetically cocoa powder, right, with my flour, so it's nicely combined, and to aerate it, to incorporate air. But you only do this after you weight the flour / you measure the flour in volume, so not before. If the recipe specifically say sift the flour before weighing it out, then there is maybe a slight difference, maybe of ½ an ounce in a cup of flour. But normally, I sift it after I weighed it or after I measured. So it's not done before weighing or measuring. By weighing the flour makes no difference because 8 ounces is 8 ounces and 80 grams is 80 grams. By volume, it would make a difference if you sift the flour before measuring it. The standard is measure the flour first, full cup, and then sift it afterwards.
Are there any more questions from the audience?
Okay, so while we're waiting for some questions from the audience,
I actually have a question.
yes.
I was looking here, and you went from grams to milliliters. Are they the same?
Okay, good question. And that's a question which my students are sometimes concerned with. So we're talking about, we're going to list 2 different things. And I'm going to ask the students to give me randomly, I ask my audience randomly to give me any kind of unit of measurement. So let's go forward and backwards between the 2. Give me any kind of unit of measurement. Inches, okay. Angelica?
Meters.
Meters, okay. Next. Anything else?
Grams.
Grams. Anything else?
Milliliters.
Milliliters. Jason, one more.
Ounces.
Ounces. And Angelica, one more.
Pounds.
Pounds. I'll be. Okay, so I let them randomly throw out some unit of measurements they are familiar with. Then I ask them, can you identify which are American and which are metric? So let's go through the list. Is this American or metric?
American.
American. Okay. Meters is? Metric. Grams is? Jason? Metric. Milliliter is? Angelica? Metric. Ounces, Jason? American. And pounds is? Okay. So we have the 2 differences. Very good. Okay. Now there's another difference is the ones are units of length. For example, inches, meters are measurements of length. We eliminate them for now. So that leaves us with grams, milliliters, ounces, and pounds. We realize that these 2 are metric, the grams and milliliters. We realize that ounces and pounds are American. Now, we have the difference between weight measurements and volume measurements. So my next question would be, Jason, is this grams a weight measurement or volume measurement? Weight measurement. And milliliter is weight or volume?
Volume.
Volume. Okay, ounces, weight or volume? Weight. And pounds?
Weight.
Okay, and what am I missing to give it another volume measurement in the American system? We had it on our gallon monster. Quart and? Quart and gallon, right? So let's do quart. Quart would be a volume measurement. Okay, so now I separated them out into measurements of weight, measurements of length, and volume measurements and weight measurements. Okay, then we're also going to realize that if, and we presume that the specific gravity is based on water, and that items like milk, oil, cream, eggs, all of those they have the same specific gravity, even if not scientifically correct, as water, then we realize that 1 pound, a pound, equals a pint. Or, how I say it, a pint is a pound the world around, which means if the specific gravity, it has the same density as the water, then a pound, which is a weight measurement, is the same as the volume measurement of the same ingredient. And the same applies for this. 1 gram equals a milliliter. And that's sometimes confusing to the students because they see the different units of measurements. We're going from volume to weight, and they don't know what to do anymore. So if I weigh out everything on a scale and I don't do cups and ounces and teaspoons and tablespoons, then I tell them if they want to do a calculation, what they really need to do is, if we deal, let's say, I say this is 10 grams and this is 10 milliliters, what you really need to do is in your mind, to do the calculation, you just have to eliminate the units of measurement and you will have no problem. So if I talk about an egg is 50 milliliter or 50 grams, in reality of things, if a pint is a pound the world around, then a gram is a milliliter as well, because we're presuming that the weight equals volume, because we're presuming that the specific gravity of that item is 1, which is the same as water. And if you think about water, we talk about ounces and fluid ounces, and 1 ounce equals 1 fluid ounce, which gives you then the explanation to why I'm mixing up milliliters with grams. Thank you.
Thank you very much. I'm sorry, but our time is up. I did have a teacher who wrote in and said that she loved the exam question. I have a feeling that her students aren't going to like you as much as they used to.
That's okay. If she has a question, more than welcome to contact Nina, and she will get in contact with me, and my contact information is posted on the website.
Yes.
And then I can, which I haven't done yet, but I will write down an example, for example, the egg boxes, and how to make the student think about how this all applies. And what I really love is, I went today to our food service and I said, you know, I need to explain mathematics in the classroom. And how do I do this? And I've been thinking. I come up with all kind of really cool stuff and how to measure things and make a comparison between the 1 and the 2. But for me, it's really important that the students can actually apply it into the lab setting, into the work, into cooking, into baking, what they learn in the lecture. And by using the magic number, by using examples like the eggs, make them think, make them follow through, allow them calculators left, right, and center. The calculator is not the answer. The answer is break it down in a way that students understand how to get from an egg to a tray of eggs, to a half a case of egg, to a full case of egg, and then how to apply it in the daily life into their work schedule.
Again, thank you very much, Dr. Tenbergen. Jason and Angelica, thank you so much for being his props and his really right-hand people. I also want to thank Eric West of the Tilt office here at Fresno State. He is our gracious and great cameraman.